Welcome everyone to the latest HatchWorks AI Lab. Today we got a special one with a lot of really smart people. So you're really in for a treat today. But first, our topic. So today we're digging into how to unlock self-serve analytics with generative MDM. And for those that don't know the acronym, MDM stands for Master Data Management. And this practice has been around for a long time now. And as the title of our session suggests, we'll be getting into a POC of how you can begin to leverage the power of Gen AI to take some of the tasks and functions of MDM and do those in a way more efficient and productive way. And then we'll ask some questions of the data with natural language, have a little bit of fun with that. But let's get to introducing our guests today. We got an awesome group. First off, our primary guest here, we have Federico Macias of Baird Warner, CIO of Baird Warner. And for context, Baird Warner is a leader in the real estate industry, providing residential and commercial, brokerage, mortgage, and title services for over 160 years. So they've been cool way before AI has been cool. And then next we have our HatchWorks AI CTO, Omar Shanti, our resident AI expert. I'm really excited for some of the dialogue we'll have between Omar and Federico there. And last, but certainly not least, we have David Barrio, Senior AI ML Engineer at HatchWorks AI. But welcome to the show, guys.
Thank you. Happy to be here.
All right. So what we're going to cover, like I mentioned earlier, we're going to line on some challenges with MDM, demonstrate Gen AI as a solution to assist with MDM, and utilizing RAG to uncover some insights. And ideally, we're not jumping through a bunch of PowerPoint. We're actually getting into showing off a POC, answering any questions you have. So feel free to drop questions in the chat. We'll answer some of those potentially during the session. And then we'll obviously have a Q&A at the end. But I'm going to first turn it over to Omar to kind of give us a rundown of what MDM is, set some context for us before we start diving into how Gen AI can be used in this space.
Wonderful, Matt. Thank you. And welcome to all of the guests. I've been seeing some cities pop up in the chat. It's amazing to see. We've got Atlanta, we've got Chicago. Please continue to drop messages and introduce yourself. So as we know, the content of this session is largely going to revolve around using generative AI to unlock MDM. But what exactly is MDM? So I'd love everyone to maybe close your eyes for a second and think of a standard enterprise company. This enterprise will have data across multiple different systems. Some of it will be transactional data, such as, let's take an e-commerce site for the easiest metaphor, transactions in their website. Others will be more informational, descriptive data around who a customer is, what they purchased, their order history, and so on. Master data management is the process of bringing together this data from all of these from all of these different systems, unifying it into a system that allows for consistent, accurate data 360. So you're effectively getting the full picture of your data, combining transactions with the more entity data that we were just mentioning. So you can think of entities like customer, supplier, and product data all brought together, assuring that the data is clean. By that, we mean that the data is complete, that the data isn't missing any fields, that it's well documented, adorned with metadata so that you can understand what the semantics behind, what the meaning behind that data is, and that the data is fresh and so on. That the data is well governed. By data governance here, we really mean the processes around data, around who owns the data, who gets to tweak the data, who's accountable for it, and so on. That gets folded into the broad bucket of master data management, because it's crucial that there's accountability over each of these disparate data sources. And then data integration and synchronization, the act of bringing all of this data together in a way that's up to date, that respects the meaning in the various systems, and that sort of removes some of the complexity and gives you a model that you can use fairly straightforwardly. The goal behind master data management is accurate and accessible data across the organization to empower data-driven decision-making at all levels. And what's really cool about today's demo is we all know that data is what underpins AI. But what we're going to see is that in addition to building AI products with data, you can actually use AI, and in this case, generative AI, to create that well of data that you can then build AI on. So rather than just use data to build AI products, we're going to be looking at how you can use AI processes to create that data, right? So that that data is there and available for you to then build your data products on top of. So really excited to get into that content with you. Next slide,
Nice.
please.
Can we open our eyes now, Omar?
Oh yeah, sorry, I forgot about that. Yep.
No, just joking. All right, and I think we'll get into the problem statement next. And I think Federico, you're going to add some context here, but really curious, Omar and Federico, a bit of back and forth around Federico, your experience to date, and then this will kind of segue into getting into the POC today.
Yeah, well, I think there's a lot of work being done today in AI to use the data today that is available to exploit it in a way to say, hey, you know, can you tell me this? Can you tell me that? A ChatGPT, tell me this about this data set. But this is a little bit more on the reverse side. How can we use AI to enhance the current or legacy systems? We still have a big problem here, which is, in our case, we have I call it 4 different companies. We are a shared service company here that we support real estate. We have a brokerage, which is the brokerage. We have title, and we have a mortgage company, each of them with their separate ERPs. And yes, we can extract it and say, oh, tell me more about these. However, if we want to have a master data of the transactions or the people who is transacting with us, we actually have to bring now the information from the outside and collate it or put it in a way that it makes sense to the legacy systems. So how can we use AI to fill the gaps, to correct the errors, so we can use it in legacy systems? And again, sometimes we have a Dave and a David. Which one is the correct one? What's the information in your CRM system, for instance? You have 2 different phone numbers or a different address, a different title. How can we actually make these, or even grab information from other places to enrich the data and to clean the data, in other words, harmonize it? So that's kind of the problem we have, and some of the things we want to solve. And of course, when it's put together, also, what can we know about these people?
Yeah, I'm curious too, like you've been using some of the MDM solutions have been around for a while, and there's some legacy ones out there. Like out of curiosity, like what do you see as the biggest gap of those and potential opportunity? Obviously, Gen AI is new, but potential opportunity on the Gen AI side. Federico or Omar, I'm kind of be curious from both of you.
Well, on my side, I see there's so many things that can be done, right? On the we talked a little bit about the cybersecurity. Who are you? Are you allowed to get into the system? That's totally different from the CRMs and the other ways. And that functionality is not offered by MDM solutions today. And there's other things that are not done by MDM real time, for instance, that you need to enrich the data. Let's say that there's an agent or somebody who requires to send certain campaign out there to their contacts, and their contacts have the relationship, because that's what we foster here in the company, for the agents to have the relationship, but they might be missing some data to connect to their customers. In this case, let's say, Matt, your customers, and how can real time that information can be provided to the agent so they can actually reach out via text message or some other method. Those type of things do not exist in at least to my knowledge in MDM tools.
Omar, anything to add there? I think Federico hit it pretty good.
Oh yeah, absolutely. I mean, Federico, I'd love your perspective. So BMW, as a vertically integrated organization, has got a really unique differentiator in the sense that it's one-stop shopping across all of these sort of hitherto disparate functions of that real estate world: brokerage, title, mortgage, etc. All of those come with their own different systems. It feels like really to unlock your special sauce, MDM is like one of the key facets over here. And that's probably very relatable for a lot of other companies. Earlier, we spoke about reconciling maybe product data with marketing data and customer lifecycle data. I'm curious if you could maybe talk to us a little bit about the upside of unlocking that data and what you can do with this sort of harmonized 360 view of your transactions, of your agents, and so on.
Yeah, it is. once you have the information, again, there is value on the exploitation of, okay, now there's an agent who needs this information, or understanding what are the different products that have been purchased by the same household. In this case, today we probably know what the products have been acquired by the same person, but maybe not by the same household. So if you bring this, is maybe Omar, you have a partner, and that person is not in the title or in the mortgage, but it belongs to the same household, and at the end, it's probably the same transaction that we're having, but we do not know that. That's one way that we can actually exploit this to understand the people in the household. And this is pretty essential when there are live events. A kid comes back from college and is living in your home, and that kid needs now a new rental or a new house to go. Other unfortunate events like divorce or anything else that could happen, that now that household is it can become some other information. But is the and how can we cross-sell and upsell to that? And sometimes we do not know that we have a customer that has done both a mortgage and another transaction with us. We try to do it, we are doing it, but sometimes it's not 100% accurate.
Yeah, if you're like me, after college, I moved back home for the free rent and the hot meals. So different scenario there. I keep picturing like Uber and Uber Eats, like the upsell, cross-sell opportunities. Drivers could be consumers, and like there's like another kind of tertiary example of where this starts to apply. But Omar, set us up in terms of like the personas we'll be considering, I guess, when we jump into the actual like POC and walking through some of these use cases.
Yeah, absolutely. I mean, it's well and good to talk about master data management as a set of technologies, but ultimately it comes down to people and processes. And here we present 4 personas within any enterprise to sort of drive home the point and make it real what life without an effective MDM strategy looks like across the entire organization. So let's talk about Teresa. Teresa is a tech exec. Teresa is looking to create this culture of data-driven decision-making up and down her company, so that everyone is able to kind of create the metrics that they need to justify the decisions at the time of proposal. She's struggling, though. A lot of her people don't have access to the correct data, even though she's been able to educate them up on the tools that they need to be able to run SQL or to get that data. And so her sort of corporate goals have been taking a hit because she hasn't been able to build to build her strategy through making smaller data-driven decisions. Santiago is a data steward. Santi struggles to ensure data is consistent across disparate applications. Santi is working for a company with legacy software and legacy systems. This company grew with a series of acquisitions. And with all of those acquisitions, these new software systems come in with their own quirks, with their own semantics, their own meanings, and their own sort of data quality issues that eat at some of his SLAs. Santiago is part of a fairly mature data governance practice, so he does have data engineers on hand who he can use to sort of help shape what the data warehouse and the data lake looks like. But Santiago is risking being another statistic. More than 50% of data warehouses fail at one point, and Santi's job as a data steward is to do his part to ensure that that's not the case over here. Deborah, for her part, is absolutely flooded. She's a data engineer. She's managing a ton of pipelines with these legacy data systems, but she doesn't have full context of what the data means. And even though she's able to work with Santiago, a lot of the information has sort of been lost through historical mergers. So she's constantly putting out fires and barraged with requests and working backwards from them. This is where Bob, as the business leader, sort of comes in. Bob was looking to kind of unlock data-driven decisions, but because the data is just not quite there, and because there's all kinds of different definitions on what data means, I think the average company has got maybe 4 BI solutions with their own semantic layers. Bob is struggling to sort of make data-driven decisions that are not based on gut feel, but based on tangible insights. So those are some of the personas that we should keep in mind as we go into this next section, when we go into the demo.
Nice. Real quick, Omar, we got a question from the audience. Randall asking, what's the difference between master data from transactional data? I think like in Federico, I think you put a response in there, but that transactional data is kind of capturing these individual events. The master data is like making sense of the connections in a sense. Is that an accurate way to describe it? Anything additional, Federico or Omar?
That's one way of saying it. And I think a transaction is usually time bound, right? It has a start, it has an end.
Yeah.
You can open a purchase order, and you can complete the purchase order is delivered, or you can cancel it. But it's well, time bound is it has a process that's been, and then a person has contact information, or a product, a 12-ounce can of Coca-Cola. It's always going to be a 12-ounce can of Coca-Cola, and it has an attribute to say how many grams of sugar and things that do not change all.
Yeah.
Well said. Another metaphor to use is sort of in sort of the data warehouse world, we talk about facts and dimensions. One way to think about this is events and attributes. So a transaction can be thought of as an event or as a fact, a measurement at a specific point in time. The dimension, just like an attribute, is sort of information around that transaction. So it's not exactly what happened, but it's information about who did that event, in what circumstance, who was involved, and so on. So master data management is sort of the process of bringing together all of that data into one source, making sure that it's all sort of cleansed and ready to be analyzed. I've been saying one source for simplicity. It might be a few different sources distributed, but we can get more into the advanced side of this at a later point.
Yeah, y'all are bringing back nightmares of joining data, inner, outer, all of that kind of stuff from SQL back in the day. But yeah, Omar, set us up with the key points we'll hit in the demo, and then a couple of other setup points, and then we'll get into the fun with David Berry here.
Yeah, absolutely. So the goal of the demonstration that we're going to see shortly is in using generative AI to perform one hyper manual, hyper tedious task, which is deduplication and cleaning data. Estimates have it at anywhere between 50 to 80% of a data scientist's time is spent doing this sort of data cleansing work. But if you think about the BI consumers and the data-driven decision makers that we were talking about earlier in the persona slide, everyone is sort of tasked with deduplicating and cleaning the data unless it is cleansed at the source. So in this demo, we're going to talk about how we identify duplicates, how we clean those, and how we equip our end users with the ability to take those rules and shift them left up to the source system. And Federico, I'd love once I speak about the other slides for you to maybe talk about the importance of bridging back to the source system and sort of shifting left with data quality. We're also going to take the concept of the household that Federico is mentioning is super crucial for upselling and cross-selling opportunities, and talk about how we can build that concept across 3 ERPs, in this case, Baird Warner, Key and Mortgage, and B&W Title. Lastly, once we've done this work of deduplicating the data, adding in a semantic concept, we'll then utilize RAG to take advantage of the semantic concept and have a natural conversation with our data, unlocking insights and unlocking this inspiration loop in a way that anyone can access, no SQL required.
Cool. All right, Omar, anything you want to, I know we've talked about several of these, but any of the challenges before we jump in that are worth noting?
Maybe one thing to call out, Federico, I'd love if anything stands out to you, but overlapping domains is a really sort of challenging one. So what generative AI is really good at doing is understanding what things mean. So understanding sort of semantics. And when you have different ERP systems, you might have the concept of an address represented in different ways. One system might have an address as a single field. Others might break it down by street, apartment, location, state, city, etc. And they all might have different ways of representing that. Using something like generative AI that's able to understand the semantic as sort of a first-class citizen, you can take these overlapping domains and get a signal from those overlapping domains so you can understand how you reconcile these. This becomes pretty crucial in the field of, for example, data integration and that shift left sort of philosophy that we were talking about earlier. But yeah, Federico, over to you. Anything stands out?
Well, one of the things I love this chart. One of the things is like anything, we are in this Gartner hype curve on the inflated expectations, right? Where we think AI is going to solve all the problems, and it's like you just have to say, hey, AI, just put together this database, build my MDM, and tell me where I can sell more, and boom, magic happens. And it's not exactly like that, and there's a lot of work. It's not a silver bullet, but definitely can help with many of these things here in terms of the data quality issues, the things that we cannot see with the naked eye. Sometimes when we do have our algorithms and things, they're very specific. They're very succinct into doing one thing for cleaning or augmenting or enriching the master data. But sometimes we're missing something, and that's where this is another tool in the tool belt that we can use as a master data management and data professionals.
Yeah, I think that's a great point. Like generative AI feels like magic, but it's not a magic bullet that you flip a switch. There's still a lot of work to be done. We're still early days, so I think anybody selling it in that way, be wary. May have some snake oil salesmen out there. And I think this is the last bit here, Omar. And we've hit on several of these. Any last ones before we turn it over to David that you want to focus on where Gen AI can help in kind of this MDM arena?
Yeah, so just to comment on what Federico mentioned, spot on. I mean, part of the challenge with Gen AI is learning where not to use Gen AI. And in this case, we think there's a compelling offering around using Gen AI in this field of master data management for some of the reasons we see there. I'll quickly browse through some of them. So we mentioned semantics. I was just commenting on it. Building sort of information around your data, what we might call metadata, to empower data-driven decisions is super important for any enterprise. Knowing where that data lives, how to access it, how to query it. That is sort of one of the main obstacles, or a series of the main obstacles around building a data-driven decision-making kind of economy at your enterprise. So Gen AI can really plug in over here with with sort of identifying data overlap, defining terms, identifying when a redefinition happens across systems. Can also help with sort of standardizing different forms of data, structures. So we mentioned address as a good example. I think at the top of the call, Federico mentioned the different ways to spell a name. So we can talk about some of those as well. And then where Gen AI sort of differentiates itself is it can sort of shift left or it can shift right. So in this talk, we're going to see how we're taking this data-driven decision-making, how we're sort of taking this data deduplication work and then unlocking data-driven decision-making using RAG, but we can also shift left and use the sort of insights that we uncover to unlock data modeling, data integration, ETL, and so on. So maybe I'll stop there, Matt, but there's certainly a lot of room here.
Yeah, I think it's probably a good time for us to turn it over to David. You want to take us away? I know you had a high level architecture. If there's any points you want to hit here before I actually jumping into the POC.
Yeah, sure. So thanks, both Federico and Omar, for the great context on what we're going to be doing here on this POC. So yeah, basically what we want to emulate here is the situation that Federico described. They are facing at Baird Warner. So they have multiple companies under their big name, and each of these companies has its own ERP, which its own data sources, and each of them has a different nature of data. So that's what I'm representing on the top of this diagram. So we are going to emulate, in this case, 3 different data sources that are coming from different companies. And we want to pass them through a process that will help us the duplicating data that is repeated across these different sources, like, for example, identifying clients or customers that are present across 2 or more of these sources, and that we might not have like that connection between them. We might be treating them as separate entities when they are actually the same client in this case. We also want to augment this data using Gen AI. Specifically, what we're going to be doing here is that we are going to add the concept of household that was also described by Federico. So we have information about customers, but we don't have that information about households, about how those households interact with products. So we want to use Gen AI to augment our data sources to include that concept as well. So we are going to start with those three separate sources. We are going to embed them, transform them into a numerical representation. We're going to go deeper into that, but that will help us identifying patterns between the data, patterns that will allow us to tell, okay, these data points are the same person actually, or they are, or they belong to the same household. And then we are going to use Gen AI to actually analyze those points that we determined and tell us, okay, yeah, in fact, these are the same person. These are, or these are not the same person, but there's a high chance that they belong to the same household. So that's basically what we are picturing here. We're also going to have a step in the demo where we are going to interact with that deduplicated, that cleaned and augmented data through a chatbot, so we can ask questions in natural language to that consolidated data source, and it should be able to answer based on this new ground truth that we are building using the AI. So let me share my screen now. We can jump into the room.
Cool. Looks like we got it, David. It's like you're good to go.
Perfect. Okay. So I split this demo into two different applications. So the first one is an application that will help us with the cleansing, the duplication, and augmentation of our data, which is the part of MDM that we have been discussing. So we have three data sources, as I described. These are emulating the Baird Warner's situation. So we have a property sales data where we have fields related to that. So we have a different clients, we have different kind of operations, agents IDs that are related to the agents that caught them through that operation, and some demographic information. We have mortgage data, which is related to a mortgage company, and we have data from the titles company as well. So we have these three different data sources. Each of them, as we mentioned, is generating data from different places. So there might be inconsistencies. There might be places where, as Omar mentioned before, where the way data is represented in one or another is different, not exactly the same. There might be situations where we have a client, for example, in the property sale data. Let's put this example, for example, Douglas here, and on mortgage data, it is Doug. It's an abbreviated version. So what we want to do is that we want to match those entries and determine, okay, they are the same person. So we have that visibility that this person is a client of both services and they are not separated entities. So the way we are going to do that is the first step is that we want to transform these data points into, or these data entries, we want to transform them into numerical values so it's easier for us to analyze them. And for this, what we're going to do is that we're going to use what we call an embedding model. So an embedding model is basically a type of language model that will transform a data entry, like each of these rows that we have on each of these tables here, into a point in a vector space. So it will look something similar to this. We are mapping points from a tabular data set into a point in a space. So each of the fields that we have are going to be mapped into a point similar to what I'm showing here. So here we have a set of multiple points. Each of these points, you can think about them as representing each of the entries that we have on all of our data sources that I was showing just before. So this is a very interesting approach because transforming things to numbers or to vectors in this case, which are just a set of multiple values, will allow us to perform operations like, for example, measuring a distance between them, which is not as intuitive if we look to the data this way. It's hard for us to imagine, okay, I can compute the distance between I don't know, this center of Mitchell Roberts and Kenneth Ball. That's like non-intuitive because they are not numbers, so it's hard to know how far they are from each other. But if we map them into a space like this, where each of these entries is a point in this space, now it looks more intuitive. We can measure a distance between two of these points in a deterministic way, and we can this way calculate which points are closer to others, for example. So this is the intuition behind the embedding models. So embedding models are the models, the language models that are mapping, and this is a keyword, are mapping the semantics of one of each of these data entries into this space. And this is how this is different to some of the techniques that were used before. There are many techniques to measure distance between different strings, for example, like Levenstein distance and others, but most of them are based on the syntaxis instead of on the semantics. So they are based on on the characters that are structured in the string instead of the meaning behind that string. So that's the main difference here, and that's why this approach is so powerful. Each of these dots represent the semantics, so they represent like the meaning behind each of those data entries. So that's the first step that we are going to be performing. So once we transform all of our data entries into points in this space, we are going to calculate distances between them and find points that are very close to each other. Like, for example, these 3 points that I have here. This is just an example for visualization. Keep in mind that also this is a 2-dimensional visualization. The actual data that we are mapping is going to be mapped into a higher dimensional space that will be much more representative, but it's not easy to visualize. So that's why we are using this visualization as an example here. So once we calculate those distances, we'll have points that are very, very close to others, that are below a threshold of distance that we can define, usually by experimentation or by statistical analysis. And once we have points that are close, those are our candidates for being the same data entry or belonging to the same household, for example. So this is the interesting part. Now that we have those claims, we have points that are candidates, or that we can say or think that they are the same point or the same or the same household. We will send them to an LLM, in this case to a model similar to ChatGPT, which is more familiar for most of the people. And we will ask a question. I'm actually going to show it here very fast. So this is the prompt that we are sending to this specific model. Are these 2 entries, we are going to send them 2 by 2. We want to analyze 2 by 2. So we are saying, are these 2 entries the same person or the same household? Respond with same person or same household or no. So we have, like, we're going to classify using this predefined prompt, where each of these points or each of these pair of points are actually the same data entry or the same household or nothing at all, just a false positive that we got from our similarity search approach here. Okay, so this will allow us to basically enable or use the semantics that are captured in these points to generate candidates, and those candidates are going to be sent to an LLM or a large language model to be analyzed and classified as same point or same household or not at all. And that's the process that we are doing here. So I already ran this process because it's taking a few minutes, but I want to show you how it looks like. So these are some of the candidates. So for example, if you see here, it found on one source, this person, Mr. Roberts, and then in another source, it's represented as M. Roberts. They also have a very similar address. So when these 2 points were mapped into the vector or the numerical space, we found a similarity of 0.82, which is higher than the threshold that we defined for this example, which was 0.8. So we can claim that they are very similar. And then these 2 entries, the complete entries here, I'm just showing the name and the address, but the whole entry is going to be sent to an LLM. So it can tell, okay, they are the same person or the same household or nothing at all. And basically what we have here are the values that we verified through the LLM to be exactly the same data point. And this is what we get in the end. So this is a representation of what we get. So for each of the matches that we claim to be the same data point, we assign them a unique ID that will relate them through the 3 different data sources. We will know, okay, they have the same unique ID, so they are the same person. And also we added this field for household ID, which is very similar. We're going to have a unique ID for every household that we found within our 3 data sources. So
Hey, David, real quick,
yeah.
I got a question in the chat that I think just we'll hit it right now because it's topical for what you just ran through. But Jeff was asking, how reliable is the LLM for this process relating to like the accuracy rates? I'm almost curious, like either David or Omar, to answer that question, but also like what factors play into that, whether it's the model, the prompt you're asking. I'm sure there's like different components that start to play into that element of accuracy.
Absolutely. Yeah. So there are many elements that you have to fine tune usually. One of them is the LLM itself. There are even LLMs that are fine tuned to perform this kind of action. So that's a good idea to use an LLM that is not general, but that it's fine tuned on this kind of discrimination task so it can perform better. We know this is of course a non-deterministic process, so there's a level of uncertainty on each of the classifications. But if we use an LLM that was fine-tuned for this specific case, we can guarantee that the success rate is going to be higher. We can think about this as a classical classification task, and we can rate the LLM performance with a metric of accuracy, for example. That could be a good practice before implementing one of these systems in production, to have visibility of the accuracy of a system and to understand what's your tolerance, of course, to that accuracy. So if you want to go to 90% of accuracy or higher, and that's a good practice. So in case an LLM is not fitting that level of accuracy, you can think about fine-tuning, for example, as an alternative to make it better. The same thing applies to the model that we are using to create the vector representation, because that's also a very important part of the process. And you can do a similar process. You can fine-tune one of these embedding models to be specific for this task and to try to achieve the levels of accuracy that you're looking for.
And you mentioned deterministic there. So that's effectively like, think of it as like, if this, then that, like it is determined it's what it's going to be or the conditions to meet that. Whereas this, in a sense, is probabilistic, right? So you're dealing with probabilities and whatnot, just for folks that may have heard that word and curious how that ties.
Absolutely. Yeah. This is probabilistic, and that's why we have to think about it as a statistical problem and probabilistic problem. And that's why we need to find metrics of accuracy, of sensibility, and all of those metrics that are associated with this kind of models. So
Yeah,
that's
so we can take this further and sort of zoom out a bit. There's the embeddings model, which we can evolve. There's the distance algorithms that we can evolve. And there's sort of any data transformations we want to do, right? We can add in more fields. We can convert the name to sort of a phonetic, sounds like representation of that name, etc. So sort of feature engineering prior to doing that embeddings work. And then, as Davs was mentioning, sort of the LLM side of things as well, where we sort of prompt engineer it into identifying the rows with the distance threshold. In terms of accuracy, I think we are, this isn't something that just lives in the lab. This is something that is a pattern we've tried and tested on client projects, and the results are good enough to sort of to build on, right? To take into production. So I think, depending on your use case, depends on how important accuracy is. We see this as more of an augmentation rather than an automation play. And good enough for us means unlocking a number of man hours that would have been spent doing this data deduplication work. And for many, that is enough to act on.
Cool. Appreciate the context there, guys. All right,
Yeah.
David, keep it going, man.
Okay, perfect. Okay, yeah. So now that we have this deduplicated data with our concept of household, with different entries from the different data sources consolidated into a single place and deduplicated across the different ERPs, we can this can enable many things, as Federico and Omar were discussing before. But one of the things that I would like to show here is that this can allow you, for example, to self-serve analytics, because it will simplify the process of extracting valuable information from this data source compared to having to go to 3 different sources of data with very complex queries or ETLs. Having this like consolidated representation will allow for easier analytics, even for non-technical people or users. And that's very interesting because we can also use LLMs and generative AI on that front, and that's part of what we want to show here as well. So I built this other application, which is taking as input that duplicated data set that we generated through the process that we just described. And I would like to show what's the value in this, especially, for example, for the case of Baird Warner. So, for example, let's think about an easy question now. This is a chatbot that will allow us to interact directly with the data. This is a structured data. So let's come with a first question, like, for example, what's the average annual income on clients?
And this is essentially the RAG component for those that may not be aware of the retrieval augmented generation that's kind of allowing you to unlock this proprietary data you have with natural language versus sending off a ticket to an engineer or somebody in IT to write a SQL query and go through that whole painful process.
Absolutely, yeah, that's the whole point here. This is a retrieval augmented generation on a structured data. There are different variations. Usually, retrieval augmented generation is associated to non-structured data like documents or images or different kind of unstructured data. But this is how we can apply it to a structured data like what we have here. So how this is working? Basically, I'm going to show you a couple of prompts here very fast. 1 second. Okay, yeah. So here, what we're doing is that we're transforming the question that the user is asking into an actual SQL query that and that's done by an LLM. So that's exactly what we're doing in this prompt. In this case, for these demos, these are pandas data frames, but this can be generalized to SQL queries and any kind of data extraction code that we can think about. So we are providing the schema or the structure of our data to the LLM here as part of the prompt, and we are telling it like, okay, we are also providing the user question, and we are telling it like, okay, based on the schema on the user question, please generate a query that will extract the data that will answer that question from the user. So this is the first step here. So this prompt will go to the LLM and will generate that query. Then that query will be executed. We will retrieve the data from our data source, and another query will come here. Sorry, another prompt will come here that will send again the user question and the data that will retrieve to that query, and will generate a response for the user in natural language. So these are 2 queries, and you might wonder why this is so fast, why this process is so fast, and it's because we are using Grok API here, which is a very fast API provider. But basically, we are doing these 2 steps. We are generating a query, 3 steps: generating the query based on the question, executing that query to retrieve the data, and then based on that data, we are generating a response in natural language, like what we have here. So that's exactly what's going on under the hood.
And maybe while you're typing the next question, David, we got another question in the chat from Steve. So you mentioned in banking, the distinction between accounts, customers, and households is very important, nuanced, complex, and often held in disparate repositories. Can you use this Gen AI MDM methodology to introduce a hierarchical overlay that makes sense between those sets and subsets? And I'll let y'all answer it, but I believe like the use case we're kind of hitting here, yes, it's in real estate, but it is applicable in terms of the similar kind of complex and pain point that we're addressing. But curious, Omar, David, Federico, any comments on the banking side of things?
Yeah, I'd be really interested in Federico's responses. I'm going to take this question and unpack it a little bit. So there's a few parts to this. Firstly, Matt, yes, everything that we've shown today can be applied across industries. Anywhere where you have multiple ERP systems, you have the task of metadata management. Anywhere where you have any sort of software systems, really, you have the chance of sort of falling into the trap of master data management. In the demo that we showed today, we were mostly tackling topics of data quality and cleansing. Those are persistent across any org with any sort of digital landscape, banking or non-banking. The question is more focused on the data modeling side of things. Generative AI can help sort of supercharge some of the data analysts who are currently going system through system, trying to understand what the whole sprawl of tables each mean, which tables are currently in use, basically working backwards from data observability and sort of data cataloging. Generative AI can help there. There are sort of custom-baked tools that do empower you to do that work. So there's sort of the question of build versus buy there and using the right tool for the job. But generative AI certainly can play a role in supercharging your people in the data modeling world. Typically, there's a step of bringing various stakeholders into a room. You can do some of that pre-work with generative AI to make that session shorter and more productive. So you can sort of work towards removing a major bottleneck around sort of enterprise-wide data modeling or canonical data modeling initiatives using some of the semantics of Gen AI. But again, the question is, would you not rather use like a data lineage, metadata management, data cataloging tool, something like that instead, or find a way to do so in concert? So I hope that answers. The last thing is sort of this RAG-based query side. Whatever your data model is, what Davs is showing over here is the ability to go from text to SQL. So on the back end, what the system is doing is, I suppose technically not SQL, but pandas and data frames, but it could just as easily write SQL code against your data marts. So in that same way, you can sort of self-serve to analytics with this more complicated overlay. Federico, love your thoughts as well.
Well, the short answer on this, yes, everything is possible with time and money, technology at least, right? So in this case, yes, you can do it. And I think the easy part is actually to find these relationships and in the master data with AI. And I think what we're also trying to do here is how do you transfer that knowledge back to the legacy systems? And that is the complex part into what does that mean for your mortgage company in a bank or for your other services or that are in a bank or whatever. And that is the secret sauce that we're not telling you here, everything for Baird Warner. But yeah, the ability, it can be done.
And I think you hit on a key point. Like, don't feel like you have to solve all of MDM's problems in one shot with Gen AI. I think the key thing is like identifying some specific use cases. Could be something small like we're doing here, which is like deduplication. Validate that, get that working, then move on to the next thing and progress that way. I think a lot of times folks feel like they got to like hit, ascend this mountain in one shot. I think the iterative approach, like, we've all been accustomed to with Agile is the way to go there.
Yeah, wait until the IRS tells you, hey, we found that you've been transacting these things over here. It seems it's you. Here's the bill. So anyway.
Yeah, there you go. Assess ROI, risk, all those things when you're thinking through the use cases. But yeah, it looks like, David, we've had a few other questions you've been popping into the RAG, if you want to voice over some of those.
Yeah, sure. So I added a couple of questions. These are interesting because these are leveraging the like the augmentation that we performed with the data, or like the part of the value that we added on the previous step that was about the duplicating and adding these unique IDs to each of the fields across the different data sources. Because, for example, if you see here, the second question that I asked was like, okay, what is the minimum salary among clients with multiple services? So this wouldn't have been possible to answer without the previous step of finding these unique IDs and matching them across the 3 different data sources. So now it's saying, now it's analyzing. And if you see, I forgot to mention that I added this unique ID to each of these data entries that we deduplicated. And this is, here we have a representation that is like a consolidated data set, but this might not be applicable for every use case. Maybe we can keep the data sources separated, but with this unique ID that kind of makes sense across the 3 of them. The same with the household ID. And basically what we're doing here is like asking like, okay, among clients that show up in different services, in more than one service, what is the minimum annual income, for example? So this can help us unveil, for example, some patterns about the personas, or the kind of personas that are willing, for example, to buy more than one service. That could be
At one point, this is all synthetic fake data, so
yeah, exactly. Yeah.
you won't get anything from the
Oh
invite.
yeah,
This is not
absolutely.
real Baird Warner data.
That's a good point. Yeah, this is all synthetic, so probably it don't make a lot of sense, but but yeah, that's the idea, to represent the same structure. And here is another question that is using this same augmentation, and it's like, okay, what is the ID of the agent that was able to do more cross sales? So, for example, who was this agent that was able to sell more than one service? And okay, now since we are representing our agents in this synthetic data set just as numbers, it's telling us, okay, the agent ID with more cross sales is 1000 agent. So that's also adding value, because it's telling information that it's coming from the 3 data sources, where it needs to use this unique ID to consolidate the 3 of them and kind of analyze them in a more holistic way. So that's what I wanted to show
Awesome.
with examples.
Good. Yeah, great POC there. I'm sure there's a million other questions we could start asking there, but we only got about 5 minutes left. So I do want to open it up to the chat. If anybody has any other questions, please drop them in. And you know, if we do need to go along, a few of us can probably stick around and keep chatting. But it looks like we got another one from Steve, and then also Omar, if you got any questions, Federico, if you got any questions, I probably got a couple I want to ask too. But Steve goes, what's your approach for verifying these natural language answers to David's question? Oh, that's interesting. So you get the response from the LLM. Is there a mechanism you can use to kind of validate the response? So kind of a another agent acting, AI agent acting in another task maybe, but curious y'all's thoughts there.
You just stole our thunder, man.
It was Steve's coming with the good questions. Yeah.
And Federico, I've got some perspective. Would you like to share yours? If not, I can go ahead.
Well, the thing is, Steve, there's a role today that exists that is called in the human in the loop, which is the data. I would put it out there. The data steward, and that is the person who makes sure that the data is correct to some degree. Now, AI will help this data steward to automate most of this. By the way, data steward is not just a person looking at the values. It's somebody who's actually making code in Python to actually enhance the algorithms to have a higher matching percent. So that's kind of like the quick answer to how you verify these.
Yeah, and Steve even mentioned too, he caught something in the response where it said approximately 95,521 and 91 cents. I think like the key point that triggered that for Steve was like the use of the word approximately and such an exact figure too, right? Any insight into that?
Yeah, so there's sort of a trick here that that I think is the way that we think about testing language-based experiences at HatchWorks, which is decoupling the semantics from the syntax. Historically, when we write unit tests, when we test a piece of software, a function, for example, we provided inputs and we say, give us the output, and we make sure that the output is equal to exactly the output that we expected. In generative AI, because this is probabilistic rather than deterministic, that kind of to the letter testing doesn't work so great. So instead, you want to take the utterance, read past the letter to understand the meaning. In this case, the meaning is in the 95,529 number. Because this is sort of, there's a query underpinning this on the back end, there is a way for us to sort of execute a query and then verify that the number that we get out of that query is equal to 95,529. We could do that manually, or we could do that agentively. Whether we try to do that agentively, it doesn't get us away from the human in the loop, because we do need someone to make sure that right now the system is functioning and it's not just one bot saying another bot did the right thing when it did the wrong thing. But in many cases, you don't have a financial thing to fall back on. So let's say that you've built RAG at your enterprise to answer policy questions or privacy questions, etc. Then you can't just really execute a SQL query on the back end, get a number, and then make sure that it's the same number. Instead, you need to make sure that the meaning is the same. And so we can speak more about this probably in another session. But in the HatchWorks lab, we're cooking up a way to sort of test your models at scale with human in the loop too. And that is built on this syntax versus semantics idea. And the premise is Gen AI is really good at understanding the semantics past the syntax, and traditional deterministic coding doesn't really honor that distinction quite as well. But yes, to go back to Federico's point, the human in the loop plays a key role. And if you have bad data, then even if the generative AI model executed successfully, it's still going to return bad results. So that's part of this too.
Cool. Yeah, it'll be interesting to see how that evolves over time. Because I love the human in the loop concept where they're not having to do all the work, but it's kind of another mechanism to check. And I think based on how important being accurate is a key element too, but seeing how that evolves. And is there a point where probabilistically you are more accurate than a human, but the fact that a machine's getting it wrong, does that cause problems? Like that's a whole nother like theoretical type of discussion. But we got a few more points here. We got a couple thank yous, and yeah, Federico, if you have to jump for another meeting, appreciate you being here today. We can stick around for another minute to answer any other questions, but really enjoyed your perspective from the actual industry and kind of what you're going through as a CIO.
Thank you, everybody. Have a great time. Have fun out there.
Thanks, Federico. Yeah, I think Jeff just had another point. Also didn't quite understand the question with more than what. So I think that's another piece too. Like the prompt you're giving is a key element as well, in a sense, right?
Yeah, that's a good point. It was meant to be the must. Actually, it's like the agent with the most cross sales. But that's one good thing about LLMs. They can kind of interpret what you're trying to say, even if it's not exactly.
And that's what you meant. Yeah.
Exactly. It can, because it can extract the semantics, even if the syntax is not completely accurate. So that's a great point. Yeah, it was meant to be the most. And what
you're sure it knew what you meant?
Who was that chatting? And if you want to jump in and talk, feel free to ask.
That was me. This is Jeff. I was curious.
Jeff.
So it did know what you meant?
Yep. Yeah, it did, because I have tested some of these questions and I know this database and I have tested with the manual queries, and that's the right answer. So yeah, it could understand what I mean.
I think what's interesting too is like you could add an element where, maybe it is clarifying if there are some semantic questions there. Like it's because I think a lot of times LLMs, their intent is just to provide an answer and just kind of go with it. Like, so I've seen some instances where you can build some of that into the prompt. Like if there is any like fuzzy areas or it's unclear, then ask a clarifying question.
Yep.
So there could be some of that you could do to kind of counteract if, the human in the process is maybe asking an unclear question or something that doesn't quite jive.
Yeah, absolutely. And I think one thing to call out in this demo that we just saw is This pattern allows us to basically execute any workflow that we would we can sort of build with LLMs. And so what I mean by that is, in the same way that David was able to execute a pandas query, we could have hit an API and awaited the response. Could have gone back to the user, as Matt mentioned, for clarifying questions. Basically, we are not just using the LLM as one-stop shops, but we're building workflows in which the LLM sort of tells us what queries to run or what actions to take. This way of working with LLMs is sort of called the agentic model, and it just opens a lot of doors around getting to the right question in order to get to the right answer using the right data sources, and a lot of potential there.
Cool. All right. Any last questions before we wrap it up? We got a few solid demos.
Are you seeing,
jobs,
is
pats on the
this,
back.
are you seeing this, are you putting this into production anywhere, or is this still sort of demo POC stuff?
This here is definitely a POC, but Omar, I'd leave it to you kind of on the getting some of this stuff into production and processing.
That's right. Yeah, that's right. Thank you for the question. So as mentioned, this is us proving out a pattern that we were able to take elsewhere into, or we're on the verge of taking elsewhere into production. We just got a message saying RAG as a service, and actually that's sort of exactly it. We do have a RAG as a service offering that enables RAG, but this is sort of building on top of RAG as well.
Yep.
So all specific similarity search and data deduplication, which, as mentioned, we've sort of taken this pattern and we're on the verge of going to production on a client project with that. So
Nice.
Yeah.
it's
And
not
one
just
case study that's out there, I think you mentioned RAG as a service, like the one that's out there and live, and we can talk about COTS 2M. So they kind of have a fleet management solution. So using something like this, so people can ask questions of their fleet, like who's speeding, how much idle time do I have, things like that. So a good example there.
Yeah, that's very similar, and that's an example of a production application using this same approach.
Awesome.
Cool. All right, awesome engagement. I'm just scanning the chat. Andy, any last things that I missed? I think we got them all, most of the questions here. But yeah, if anybody wants to chat some more, get some time with us or Omar or David, just ping us, find us at HatchWorks.com and or on LinkedIn. I think Omar just had a really good podcast episode we did with Talking AI, really good perspective there. And we got some other good content around this and RAG and all kinds of things that you can check out and enjoy at your leisure. But thank you everybody for joining the lab today.
Thanks, guys.
Bye, everybody.
Okay, thanks everyone.
Thank you.
Thanks, everyone.
Thank you. Bye-bye.